Callum.
Where do you believe humans will inhabit next, or will we remain on Earth indefinitely?
Where are you? I couldn't see you anyway.
Down here.
Oh, you're
Down
there,
here.
right? I mean, it's a question for my NASA friends. Actually, I mean, I suppose that the moon is the obvious answer. We talked about this last night a little bit, actually, because moon bases are the easiest things to build. But Mars surely is the next ambitious destination for human exploration of space. I hope. I mean, I really do hope that in my lifetime we land on Mars. I'll be so disappointed. I mean, I was told in the 1970s we'd be there in the 80s. If we would have been, it would have felt like it, to be honest, I think. So my genuine hope is that we've got beginning to build bases on Mars. I want to see that, or I'll be very disappointed with the human race. I'll be wandering around like that going, oh, you silly sods. Anyway.
We'll move on to a less depressing question, I think. Thank you, Callum. Ramsey Grammar School, Zach Geary, I think that's how you say it. Zach.
Do you think we can get to a stage in science where the human mind cannot comprehend how things work?
It's a good question, that, because it's been quite hotly debated recently, because a colleague of mine at the Royal Society, Lord Rees, who's the president of the Royal Society, wrote an article suggesting that might be the case. Because I don't agree with him, actually, because I've seen no sign of that at the moment. His view, though, was that our attempts to understand gravity, to bring them into the fold, so these are theories like string theory, for example, have been very, very difficult. In fact, they seem in some ways to get more difficult the more we try and dig down. So I suppose it is possible that the underlying workings of the universe don't carry on this trajectory of becoming simpler and simpler and simpler and more understandable. And you reach a point, and some people suggest we may be at that point where when try and understand gravity and the way it works at a very small subatomic level, so-called quantum gravity, we just can't do it. But I see no evidence of that. I see what you call this reductionist project of the closer you look and the more you understand things, the simpler and more beautiful they become. That's done very well for us. And remember that it's not just esoteric, because I kind of mentioned that quantum theory, which is one of the most esoteric things you can think of, tells you how transistors and silicon chips work, for example. So that exploration of the esoteric universe has delivered actual technology, all our technology. So I don't see any sign of that. But I suppose you have to admit as a possibility that the universe might be so complex at some fundamental level that we're just not capable of understanding it, but I don't think so. And anyway, we'd better go and find out where our knowledge stops, and we're not there yet. So.
Okay, thank you. And we now go to Alex Eaton, Queen Elizabeth High School.
How likely is it that there is life on other planets or celestial bodies, and will we ever find it?
That's what I learned through certainly doing the Wonders of the Solar System series, where we spent one episode looking at this, was that the consensus seems to have shifted over the last decade or so. And now I think with the discovery of clearly that there's an ocean beneath the surface of Europa, one of Jupiter's moons, which has got, I think by many estimates, more water in it than all of the oceans of the Earth combined. Now we know that water is a prerequisite for life. In fact, on Earth, wherever you find water, you find life. And if there's no water, so some areas of the Atacama Desert in Chile, there's no life. So there's plenty of water out there. Mars as well, the evidence now seems to be very strong that there's probably water subsurface on Mars. And there are some tantalizing hints from Mars. The way that methane shifts in the atmosphere, depending on the seasons, seems to suggest that there may be some biological activity there. These are controversial things to say because it's a controversial area. The way we're going to find out is to go and look properly. We did that in the 70s with 2 missions called Viking. They looked, they didn't find any evidence, although there's some interesting and controversial hints. So the next mission, which I was involved in reviewing actually, which was called ExoMars, which has now become a joint European NASA mission to Mars, is a mission to go and seriously look for life again in a way that we did in the 70s, but we haven't done since. And I think a lot of people think that the odds are that we may find signs of either life that was there that is now not there, or perhaps even living organisms on Mars. So if I had to put money on it, I'd say it seems to me that the evidence in favour of microbes out there in the solar system seems to be, it certainly suggests we better go and look. So here's the thing, because I think it would be it's one of the greatest questions that's been asked in human history, right? Are we alone in the universe? We actually know how to try and answer that now. We go to Mars, we go to Europa, we have a look. And it would seem to me to be, given that it's one of the great questions, it seems ludicrous and idiotic to think that we're not really trying very hard now. Now we've seen hints that we're not really trying hard to go and look. I do not understand why we're not there now, digging underneath the subsurface of Mars to look. Because it would be a profound shift, wouldn't it?
Okay. Right, Brian, we now have a question from Owen Atkinson from St Ninian's High School. Owen.
What scientific questions do you hope to have answered in the next 15 years?
Right, so the one I know will be answered, and this, I almost get accused of being unscientific, but we know that we'll see the origin of mass in the universe. As long as the LHC continues to work as it's doing today, because it's running today and taking data, if it does that for another year, we'll answer that question one way or the other. And that's profound, as I said, because it's not just that question, it's blocking our understanding of the fundamental forces of nature. The big questions, there's the strength of gravity, which I'd mentioned. There's two things I didn't mention. It turns out that 96% or so of the energy in the universe is not taken up in the form of the particles that we can see. So this matter here is a small amount of the actual matter in the universe. There's something called dark matter that we have very strong evidence for now. So it's almost certainly there. It's almost certainly some new kind of particle, but it doesn't interact very strongly with normal matter. And the LHC has a good chance of seeing what that is. There are also other experiments that have a good chance. So we may uncover I suppose the substance that makes up most of the matter in the universe. We don't know what that is yet. Then the other thing, which is a bigger mystery, which is why I said energy rather than matter, is that this stuff called dark energy. We have no idea what that is, but it's causing the universe to accelerate in its expansion. So we're fairly sure now that the universe is not, it didn't begin at the Big Bang and it expanded, and then because there's lots of stuff in it gravitating together, then it slows down. That's the standard picture. But actually it turns out the universe is speeding up. And this is an observation that's been confirmed in the last decade or so, using things like the Hubble Deep Field image, actually. And so we don't know what that is, and I would love to see an answer to that question, because there's something profound that we don't understand about the way that gravity works, I think, or certainly the way that all this energy and matter in the universe interacts with itself to produce the universe that we see. There's something very odd operating there. And as we get better and better measurements, we begin to see in more detail how we might answer them. So I'd hope we'd answer those questions.
Good. Right, we now go to Castle Rushen High School and Lawrence Couch. Lawrence. Up the back.
Why has the Higgs boson not been discovered yet?
That's a good question, and the answer is that we know it's very massive. So we think that it's something like, let's say, 120 times the mass of the proton. So you make particles like that in particle colliders by having enough energy to make it. So it's E equals mc squared, Einstein's famous equation. If you want to make something very heavy, you need a lot of energy. And also, when you make Higgs particles, if we think that we know that they exist, or we're looking for them, we have a theory that predicts them, then our theory predicts that they're made very rarely. So you need two things. One is you need enough energy to make them. And the second thing is you need enough collisions per second. You know, I said 600 million collisions per second is the design rate, collision rate of the Large Hadron Collider. So you need lots and lots, billions actually, of collisions in order to make enough of them, because they're very rarely made, in order to see them. So the LHC is the first accelerator that has definitely had both the number of collisions you need and the energy you need to make them if they exist. It could have been seen at previous accelerators if we were lucky. So it was on on the light side are actually a little bit heavier. Because of difficulties in the way you see it. It's a bit paradox, actually. It's easier to see when it's heavier in some sense. But anyway, basically we've not had accelerators of enough energy or enough brightness, enough collisions per second to guarantee that you could see it or to rule it out. But this is where the LHC is real science, because it is capable of completely ruling out the existence of a Higgs particle for the first time, which is in many ways why we built it with the energy that we did.
Right, Hannah Short from Ballacomine High School. Hannah.
Hi. Do you think there is such thing as a parallel universe?
There we are.
Where are you? I don't know. Well, I mean, as I mentioned, there were different kinds of parallel universes, actually. One way is these sheets that I described, so real bits of space and time that float around. And I mean, who knows? They're theories, but there are signatures at LHC, for example, that we could see that would lead us to believe that's the way the universe is. So that would be an experiment you could do. The problem with many of those theories is you can't rule them out. So that's why some people are quite antagonistic towards them, because the key to really doing science is to say things that you can test. And so you can test it positively, like we might see the signature of them, but you can always dodge it with extra dimensions so that you can have them that you wouldn't have been seen at LHC or wouldn't be seen in some signature in the sky. But there's the other bit, which is in quantum mechanics, which is the so-called many worlds interpretation of quantum mechanics, where the universe splits every time anything interacts with anything else. So every time a single photon of light goes into your eye and interacts with your retina, then the universe copies itself, all the universe, into two. It seems ridiculous, but that's one of the mainstream interpretations of quantum mechanics. And again, it's very difficult to move that beyond philosophy. So therefore, I don't want to talk about it because it's philosophy. but actually, so there are quite a lot of different kinds. Actually, Brian Greene, the author who wrote The Elegant Universe, is a wonderful author, has written a very good book, which his most recent book, I can't remember what it's called, but it's the most recent one if you look for it, which addresses this in a beautiful way. Many of these theories of parallel universes, might be called parallel worlds or something, I can't remember. But that's worth getting, actually. And he makes the argument that it's not entirely philosophical, and therefore worth considering. I shouldn't say that. I'm sorry if you're a philosophy student. I have a track record of annoying philosophers. Yeah.
We'll go then to Vori Baker from Ramsey Grammar School. Vori.
Are there any other planets in the universe with an atmosphere like Earth's?
That's a great question and an experimental question now, and the answer is yes, there are. We've discovered planets with atmospheres. We've discovered, the number changes all the time. There's a spacecraft up there called Kepler, I think it's called. Is it called Kepler? That's looking and finding hundreds. I think it's 600, 700 planets in different solar systems. So I think the consensus now is virtually everywhere you look, when you've got the technology to see it, you start seeing planets. And there was recently, I think, a quite Earth-like planet discovered, in the sense it's a rocky planet. I think it's quite a bit bigger than Earth. And it's in the region around the star where you can hang on to an atmosphere. It's got more gravitational pull than the Earth, actually, so it's very likely to have an atmosphere. The question now is it Earth-like? And the real question, the fascinating question, is does it have oxygen in it? Because the way that oxygen got into the Earth's atmosphere was through photosynthesis. So there wasn't much oxygen. I think the number is something like 0.0005% oxygen before algae initially, and then the plants put oxygen into the atmosphere. So what you can do, and what we now have the technology to do, is to start watching when those planets cross the face of stars and look at the starlight going through the atmosphere of the planet, and from that you can measure directly what is in the atmosphere of the planet. And so it's conceivable that we're going to find life, or the signature of life, on a planet around a distant star before we find it in our solar system beyond Earth. But the answer is yes, we're seeing Earth-like planets now. And you can watch, it's worth going on the web actually and watching, because every day almost there are new planets discovered around distant stars. Some quite, I think it's quite close, the one, it's within 25 light years or something, the one that's very Earth-like that we found. So it's almost conceivable we could go there. It's not that far. No.
Thank you, Brian.
You can go. Do you want to go 25 light years? Yeah.
I'm sure you've now given a good question for the astronauts to have to answer. So they've got a bit of time to think about that. Just on a lighter note, because that's really all the questions we had that we've got for you, except one that just thought might be an interesting one for you to answer, Brian. And that's a student asked, why did you name